We've been playing around with the movie lens dataset. Let's get started now with actually writing some code to find recommendations for a particular user. First, we'll use a neighborhood-based collaborative filtering method. Collaborative filtering uses user rating data, which is exactly what we have with the movie lens data. It's a neighborhood-based model because we are going to find the k nearest neighbors of a user, the ones who are most similar to a user, and then use their ratings to predict what the rating of the active user would be for a movie they haven't rated yet. The active user is what we call the user for whom we are finding the recommendations. First, we'll represent each user as a vector. Each element of this vector will be that user's rating for one movie. So since there are 1600 odd movies in all, each user will be represented by a vector which has 1600 odd elements. Each of those elements will represent that user's rating for that particular movie. If the user hasn't rated a movie, then it will just be blank. Now, the blank is represented using a constant called np.nan. This is a value which just means that the number doesn't exist. Nan is similar to a null value in SQL, and if you try to perform any mathematical operations with nan, the result will also be nan. So, adding a number and nan stands for not a number, by the way, will also give us a value which is not a number. We need to keep this in mind as we manipulate the vectors. First, let's create a user item rating matrix in which each row will be a user represented by their ratings for different movies. So this matrix needs to have as many rows as there are users and as many columns as there are movies. For this, we'll use a pandas pivot table function. The pivot table acts very similar to a pivot table in Excel or a group by in SQL. What you're doing is you're taking your data and saying, take the user ID column and make that the row index. Take the item ID column and make that the columns. Then aggregate the ratings for the corresponding user ID and item ID and put that into the values. So in the matrix, each value corresponds to a rating for a user given to a particular item. The pivot table function also takes in an aggregate function, which by default is the mean. So let's say our user had given more than one rating for a particular movie, we would have the average rating here. So this is how the user item rating matrix looks. As you can see, there are a lot of not a number values here. This is because it's expected that many movies would not have been rated by multiple users, or many users would not have rated a lot of movies. The number of movies rated by user ranges from 20 movies a user to more than 500 movies a user. So now we have users represented by their ratings for different movies. We should be able to compute the similarity between two users. So let's write a function to do so. Now the similarity could be computed using a bunch of different metrics. It could be the Euclidean distance between the two users, or it could be a cosine similarity or a correlation. We'll write a function to find the correlation, but it should be very simple to modify this to find any particular distance that you want. We'll import the correlation function from the SciPy module spatial distance. And now we're defining the similarity function for two users, user 1 and user 2. First, we'll adjust the user 1 and user 2 vectors by the mean rating for each user. The reason we are doing this is we want to normalize for any bias that a user might have. For example, maybe a user is biased to give a high rating, for any movie. Some people are just generous, and maybe some other users are more critical and would give a lower rating in general. So by normalizing for this effect, we make sure that any biases which are specific to that user are removed. So we've taken user 1 and adjusted by the mean rating of user 1. Notice how we used NaN mean as the function to compute the mean rating of user 1. NaN mean is a function which will ignore any not a number values which are present in the array and compute the mean of the remaining values. We do the same sort of operation for user 2. Now we have two vectors which have been adjusted for the mean value. We can find the similarity between the two users. To do this, first we'll subset each user to be represented only by the ratings for the movies which both of these users have rated. This is because if you try to find the distance between two users and there are some not a number values in those vectors, the function that we try to use like correlation or cosine will fail. So we are subsetting the users to the intersection of the movies that both of them have rated. These are the common item IDs. The item IDs for which both user 1 and user 2 have a rating which is greater than 0, which means that it is a number. This list of common item IDs has to have at least one movie for us to move forward. Otherwise, we'll just return that the similarity between these two users is 0. If there are more than one movie, or if there is one or more movie that both the users have rated, then we will find the similarity between both the users using the correlation function. First, we subset each of the users to have only the ratings for those movies which are in common, and then we'll find the correlation between these two vectors. The correlation is given by the correlation function which we imported from the SciPy spatial distance module. So now that we have a function to compute similarity between two users, we can use this to compute the similarity between the active user and every other user and then find the nearest neighbors of the active user. So let's define a function for that. This is a function that will take an active user and the number of nearest neighbors that we have to find. Then it will not just return the nearest neighbors. In fact, it will return the ratings of all the movies using a function of the ratings of the nearest neighbors. So it will use the nearest neighbors ratings to predict the active users ratings for other movies, and those predicted ratings are what this function will return. So let's first set up a placeholder matrix. It's called similarity matrix. This matrix will have the similarity between the active user and each other user. We're saying that the index of this data frame is the same as the index of user item rating matrix, which means that it will be the user IDs. There is only one column which is the similarity number. This will create a data frame which has an index which is the user IDs of all the users and one column named similarity. And this matrix is currently empty. And we will fill values into this data frame as we compute the similarity between each user and the active user. So we'll iterate through each user ID in the user item rating matrix index. And we'll compute the similarity between that user and the active user. We'll use the similarity function that we just wrote. We'll call that function and we'll pass into this function the row from the user item rating matrix corresponding to the active user and the row from the user item rating matrix corresponding to the current user that we are looking at in the loop. this will compute the similarity between these two users and store it in the corresponding element of the similarity matrix that we set up. Notice how we are using the lock function to index a row in a particular matrix or a data frame. So at the end of this for loop, we have iterated through every user in our user item rating matrix and computed the similarity between that user and the active user. Now let's sort the similarity matrix by the similarity value in descending order. Notice how we have said ascending equals 0, which means that the column similarity will be sorted in the descending order. Then we'll pick the top n rows or top k rows of this particular matrix, and that will give us the k nearest neighbors. Now we have the users who are the k nearest neighbors and the similarity of those neighbors to the active user. We'll use this to get the predicted ratings of the active user for every other movie. So to do that, we'll need the ratings of the nearest neighbors for all the other movies. So let's find the ratings of each of the nearest neighbors for every other movie. For that, we'll just create a subset of the user item rating matrix, which only contains the rows corresponding to the k nearest neighbors of the active user. Then we'll use that matrix to predict the active user's rating for every movie. Neighbor item ratings is the matrix that we are setting up, which will only have the ratings corresponding to the k nearest neighbors of the active user. Notice how we are able to get that just by saying get the rows of user item rating matrix which have the same numbers as in nearest neighbors.index. There's something clever that happened here. Remember, we had a similarity matrix set up. This had an index which was the user ID. It was simply the same index as the index of user item rating matrix. When we sorted this, the index also got sorted and we picked the top k rows. The nearest neighbors data frame ended up having a data frame whose row index is the user IDs of the k nearest neighbors. You can pass in this index as a list to the lock function and it will pick those specific rows from the user item rating matrix. This way we are able to directly find the corresponding rows of the k nearest neighbors by just using the index of the nearest neighbors matrix. We'll create a placeholder matrix which will hold the predicted ratings for every item by the active user. So this will be a data frame whose index will be the item IDs. So it will be the list of columns of the user item rating matrix. The column of this predicted item rating matrix will be just one column, which will be the rating that we'll predict. So we'll fill up this placeholder with the predicted item ratings, which will compute using the ratings of the nearest neighbors. So to fill it up, let's loop through each item in the user item rating matrix. So it will be each item in the list of columns of the user item rating matrix. For each of those items, we'll start by taking a default predicted rating. So let the default rating be the mean rating of the active user. This will be the default rating that every movie will get in case it has not been seen by any of the nearest neighbors of that particular user. Notice how again we are using NaN min, which means that it will find the average rating after ignoring the not a number values. It will ignore the values which have no rating. Now we'll adjust this predicted rating, the default rating, by looping through each of the neighbors in the nearest neighbors matrix. So for each neighbor in the neighbor list, we'll go ahead and add a particular value to adjust the predicted rating. First, we'll check if that neighbor has actually seen the movie and rated it or not. So if the neighbor's rating for that particular movie, the neighbor J's rating for the movie I is greater than 0, then we'll add a value to the predicted rating. This value will be first that particular user's rating for that movie, which will be simply user item rating matrix j comma I, the jth neighbor's rating for the ith item. We'll adjust this rating, however. We'll adjust it by the mean rating of that neighbor. So we'll subtract the mean rating of that neighbor from the rating that he has given that particular movie. He or she has given that movie. Instead of directly adding this value, we will multiply it by a weight which indicates what the similarity between this particular user and our original or active user. Now we're not normalizing this weight. That is something that you could do potentially. We're just multiplying it by the similarity. Another thing that you could do is divide by the sum of the similarities of all the nearest neighbors. Instead of that, we're just multiplying directly by the similarity between this user and the active user. We'll get the similarity from the nearest neighbors matrix. Phew, that was a little bit complicated, but we got through it. So let's move ahead. At the end of both of these loops, you will have a predicted rating matrix. The predicted rating matrix will have the predicted rating for every item for the active user. We just need to add this predicted rating value that we calculated as part of this loop into our predicted rating matrix or the data frame. So once both of the loops are done, just return this final matrix, and that will be the result of this nearest neighbor ratings function.